Ferdy, I was just having a look at some of the code you wrote, and I think we might need to take you into a doctor. Take me to see a doctor? Why? Well, because you were missing your semicolon. Welcome to Headless WP Rocks. If you are into Headless WordPress and considering going with a headless architecture for your next project, there's one thing you need to decide upfront, and that is what kind of API you're going to use to send and receive data between your front end and your back end. The two choices for this these days are the REST API, which is built into WordPress, and WPGraphQL. In this video, we're going to put them head to head to see who comes out on top and what the best choice is for headless WordPress projects. Before we go into it though, just know that this is no regular YouTube video.
It's a battle royale.
Let's meet our contestants. In one corner, we have the WordPress REST API. Now, the REST API started as a public project in about 2013, and it was merged into WordPress core around 2015. And since then, it's been iterated upon, and it's the primary API used for any data fetching that Gutenberg blocks need to do. So it's a core and an important part of WordPress. And our challenger is WPGraphQL. This is a free open source plugin that provides a GraphQL API for WordPress. This was originally created a few years ago by Jason Ball. At the time, he worked for a large media publishing company, and they were trying to use the REST API to do content syndication. So one WordPress site would publish some content, and they wanted to send that same content and have it published on other blogs as well. They originally used the REST API for that, but found it to be inefficient. And when they switched to GraphQL, that was the solution to all their content syndication, latency issues that they had, and they found it to be a better solution. So since then, Jason has really doubled down on that and made it an open source project. So now it has a team of contributors and a community around it, and a lot of folks using it for headless WordPress projects. Both of these options are similar in that they both receive HTTP requests. They do some work, usually fetching data from a database or saving data to the database or firing it off an email, things like that. And then they ultimately return a JSON response back to the client. Beyond that similarity, though, there are some pretty stark differences between these two APIs. So let's put them both head to head now and see who comes out on top. Let's first talk about the specification. So for REST APIs, there isn't one. There are some conventions and some best practices for implementing REST APIs, but really there isn't consistency out there on the web. REST APIs are kind of configured and architected however the company wants to architect them. So there are differences between them in kind of how they act. And when working with a new API, you often have to learn how that particular REST API does things that's different from those that you're used to. Compare that now with GraphQL. When the Facebook engineering team first introduced GraphQL, it came with a specification indicating the exact way that GraphQL APIs have to be built and have to work. So that means if you're onboarding some developer, onto your team, you're going to work with someone else. If they've ever worked with the GraphQL API before, they already know how yours works. So for this category, I would argue that GraphQL has the advantage. The next category is strongly typed schema and introspection. The REST API does not have a strongly typed schema, nor does it have introspection, and WP GraphQL has both of those features. Let me show you what I mean. So here I am in a WordPress backend, and you can see that I have advanced custom fields activated, as well as the ACF to REST API plugin, which, as it says, exposes the ACF endpoints in the WordPress REST API. So since I have those, I'm able to go to the /WPJSON endpoint and then see what's in my REST API schema here. So I'm looking right now at the /posts endpoint here, and if I scroll down, you can see all of the data that I can fetch about posts. So it's date GMT, the slug, the status, title, content. So if I keep going, toward the end, I will see ACF. So here it is. So here's ACF. This is what has been added by that plugin. And you can see this is all the information I have about it. Here's what it is. It exposes advanced custom fields. Is it required? No. And the type is object. If I'm a front-end developer trying to consume this API and interact with it, this is very little detail to go on right here. I just know that it's going to return an object of some kind. I have no idea, what shape that object is, what kind of data it has inside of it. Is it different for other fields? Because ACF has lots of different types of fields. So this object, does it look different for various types of fields with the nested data inside of there? I really have no idea, just based on this right here. And in the REST API, this is completely permissible. You can add an entry to the REST API schema like this, and then really not provide any detail about the fields that are inside of these objects and so on. Compare that with WPGraphQL in the GraphQL specification that does have both of those, where if you define something, as a type object, then you have to go a step further and specify all of the fields on that object and what types they are. So it's very clear to the consumer of the API, all of the data that's available all the time. If you move forward with using the REST API and try to interact with this ACF field, this is what you would find out. So on some requests, you see that the ACF field in the schema returns this. So text is some text, and then this flex field is set to null. For other pages, it looks vastly different. It can look like this. So the ACF object now, it still has that text field on it here, but for flex field, it actually has an array of objects, and each one of these objects is different. You can see they have a layout name and then, a simple string of text, whereas this one has a layout name and then tons of image data right here. So I wouldn't know that any of this is even possible to come back as return values from this ACF field here, unless I actually manually try out every single type of field that exists and then look at all of these objects that come back and then build my front-end application to consume these in this shape of data. So I much prefer GraphQL. So for this category, I would say we definitely have to give the point to WPGraphQL. And that last category is a good lead into the next one, and that is related to tooling. There are a number of REST API clients that you can use to put together your REST API requests, fire them off, and then take a look at the response that comes back. But as we just saw in this example, you would have a rough time composing these types of REST API requests when all the data you have to go on is type object. There'd be a lot of guessing and checking and making assumptions and so on. For WP GraphQL, I can use a tool like Graphical to compose my queries and mutations, and also to explore all of the data that's available to me in the GraphQL schema. So if I click on Docs over here, you can see that we start from the root query. So I'll click on that, and then here are all the fields I could possibly query for. So here's run. That's the post type that I was trying to query for before. And if I click through to that return value, you can see all of the fields that I'm able to get. So I'm able to get the author, content type, database ID, and so on. So if we keep scrolling down, we'll see where the ACF fields are exposed here. So here they are. So run fields. So these are the HCF fields that the WP GraphQL for Advanced Custom Fields plugin that I've installed on the site, this is what it exposes. So if I click on run fields here, you can see it's strongly typed, and I know exactly what I can expect. So I'm getting a date as a string, the field group name as a string, and then the miles, which is a float value. So this is huge to be able to do that. When I'm composing my queries here, I can use the Explorer then. So I can say for my runs, I want for each of the nodes, give me back the date for it, and here are those run fields. So I want the date that the run was logged. I want the miles, and then the field group name. How about? So when I fire that off, I know exactly what shape the data is going to come back in and all the types. So here it is. So string, and then this is a float because it can be a decimal sometimes, just like that. So this is huge for having a lot of confidence in your network requests that you're making. I know that if in my front end app I fire off this request that looks exactly like this, the data I get back is going to be in exactly the same shape, and I know all the types as well that I can expect to get back on the front end, and there's no guessing involved. So since GraphQL has these strongly typed schema and introspection features that allow for really powerful tooling, I have to give this point to WPGraphQL. Next up is performance. Let's say in my front-end JavaScript application, I want to display a list of posts, and I want quite a few. I'm trying to get the first 100 posts, and on those, I want the ID, the title, date, and then the avatar URL for the person who wrote that post. To get this data in the REST API, you would need to fire off a request that looks something like this. So /post and then per page equals 100. I'll hit enter here and we'll see how long this request takes via the REST API. All right, so that request finally finished. And you can see in the dev tools here, the time it took is 10.42 seconds. All right, now let's compare that with WP GraphQL. So I would need to fire off a similar query where it's post first 100. Instead of getting all the data about posts, so I'm able to specify just what I want. So I want the ID, title, date, author, and the avatar URL. So I'll clear out the dev tools and we'll fire off this very similar query. All right, so that finished, and you can see in the dev tools here, it took us 5.35 seconds. So about half of what we saw with the REST API. So how can this be? How can it be that our WP GraphQL request was able to finish in about half the time as it took for our REST API request to finish? There are a few reasons for that we'll get into now. The first one is the fact that with GraphQL, you get back exactly the data you asked for, nothing less, nothing more. This is commonly called overfetching, when you're getting more data than you actually need, or underfetching, when you're getting less than you need, and then you have to make follow-up requests to actually get all the data your application needs. So with our example request that we fired off, I was, for the REST API, I was getting all of the data back about posts by hitting the posts endpoint, even though I didn't need all of it. My front-end application, as I said, only needed a few of those fields, but I had to pay the cost of getting all of that data over the wire. And that's how REST APIs work. It's a single resource per endpoint model that they have. There's some exceptions to that where if you can pass some query string parameters in the URL and get back only some of the data for a given resource instead of all of it. But generally speaking, that's how it works. So if you want data about a post and you go to the /post endpoint, you're getting all of that data, whether or not your front end application needs it. You're paying the cost for all of that. With GraphQL, by contrast, though, you specify exactly the fields that you need, and then the resolvers on the back end, on the server that resolve that request, they do the most lightweight queries possible to get just that data that you need and return it to the front end. So you don't pay the cost for this additional data that you don't actually need. GraphQL can also be faster because it supports nested relationships. So unlike REST, as I said, which is a single resource per endpoint model, with GraphQL, you can enter your data graph at any point, and then from there, you can query based on any connections or fields that exist in the data graph. So for example, if I start querying for a post, I can say for the author related to that post, get that person's title and maybe the most recent 3 blog posts that they published. And then for each of those blog posts, I want just the title and date. So right there, with that example, you can see that in a REST architecture, I might have had to first query for the post. And once I get that data back, then fire off another request to get info about the author if it wasn't included in the first endpoint response. And then once I have data about the author, then I can finally turn around and take some of the IDs for their most recent posts and then get data about those posts. So you can see how this adds up very quickly. You have these multiple synchronous HTTP requests that you have to make until your front-end app finally has the data built up that it needs. The alternative to that is to just build new endpoints that fetch all of the data for that particular page, but that gets very messy because you have some pages that might need 80% or 110% compared to another page, and to always be creating new endpoints just for those slight differences is kind of messy and time consuming to do. I think of these features that we've just talked about as hugely empowering for front-end developers. Because if I'm a front-end dev and I have one page that needs, a certain amount of data, the next page needs slightly more, the next page needs slightly less, instead of having to do these multiple synchronous requests just to gather all the data I need for every page, or alternatively, wait on some backend engineers to create brand new endpoints, each of those, returning the data they need just for those pages. Instead, I don't need to wait on anybody. If I'm using GraphQL, I can just query for exactly the data I need for those particular pages, nothing more, nothing less. Next, GraphQL provides the ability to query for multiple root resources. So that means if for a given page I need data about one particular author and one particular blog post, let's say, I can fire off one GraphQL request that just has both of those in the query. And in one HTTP request, I will get back both sets of data. So that can be a really handy tool. Another reason that WPGraphQL can be faster than the REST API is that it uses what's called the data loader pattern. REST APIs, including the one in WordPress, suffer from what's called the N+1 problem. So that means if I'm querying for 5 posts, and for each of those I want the author, then on the server, it's going to query for the author of post 1, and then the author of post 2, and then post 3, and then post 4, and post 5. You would have 5 separate queries to get the author for each of those posts. WP-GraphQL, though, figures out all of the IDs. It just gets the IDs of all the resources it's going to need at the end of the query. And then when the query is about to resolve, it fetches in the most efficient way all of those resources. So what you would end up with for a similar query in WP-GraphQL is one resource one query for all of those posts, and then one second query for all of the author details that we need. So you'd end up with 2 SQL queries being executed for WP-GraphQL. And the last item related to speed is batch queries. So in the REST API world, if you had a particular page where you needed data about a post, about a user, and about a category, let's say, you need to fire off 3 separate requests for each of those resources. Those would be 3 separate HTTP requests to the server, and each one would resolve at different times. And then after all 3 had resolved, then you'd have the data you actually need for your page. WP-GraphQL, by contrast, does support batch queries. So that means if you're using a front-end client that supports that, like Apollo client, and using its batch HTTP link that it has, then you're able to fire off one single HTTP request for all 3 of those GraphQL operations. All 3 of them will be sent to the server in a single HTTP request, and then when the data comes back, you'll have the data for all 3 of those for your current page. The next category is ease of caching. In the REST API world, because it uses a single resource per endpoint model, it's able to leverage the HTTP caching that's just built in to browsers. So for example, if I make a GET request to grab the post with the ID of 123, then the user maybe navigates away from that page, and then they come back to that page, the browser is able to take a look at the cache control headers from the last time it fetched that the data at that endpoint and realize, oh, I'm still within the window of being able to use the cache data that I already have on file. Go ahead and use that instead of firing off a new request to the server to fetch that data. GraphQL doesn't have that ability, though, because all requests go through the /GraphQL endpoint as a convention. It can't leverage the browser's built-in caching. So it requires something extra. Typically, you have to use a client-side library of some kind, like Apollo client or React query or something else that handles that caching for you. So because the REST API can leverage the browser's built-in HTTP caching without needing any third-party library to do that, I'll give the point to the REST API for this one. I will note, though, that for doing object caching on the server, that can easily be done for both of these. So if you're using something like Redis or memcached on the server to do object caching, that kind of caching works really great with either of these options. Our next category is file uploads. In the REST API world, you can have a form that's displayed to the user, including file upload fields. When the user submits that form, then you can make a post request to the backend and send along that file as part of the multi-part form data to the server, and it can be saved to the WordPress media library or or whatever else you need to do with that. And that's relatively straightforward to wire up. For GraphQL though, I'm sorry to say that's not the case. It's difficult to send multi-part form data file uploads to the server. People often resort to, even if they have a GraphQL centric app, they often resort to just sending a REST request just specifically for doing file uploads, or otherwise they'll do some tricks like base64 encode that file into a string, then send it to the server as a string, and then on the server base64 decode it, and then finally save the file. But that's a bit messy. It comes with some complications, encoding and decoding things like that, and it's a bit of a cheat, so to speak. So for this one, I will give the point to the REST API. And our last point for consideration is native to WordPress. The REST API, as I mentioned, is baked right into WordPress. It's a part of the native WordPress core application. And WPGraphQL, by contrast, is a third-party plugin that you have to install to enable GraphQL API. I have heard some members of the WPGraphQL community argue that it's actually a good thing that's not in core. They feel that they're able to iterate and improve upon the WP-GraphQL plugin more quickly with it as a standalone project compared to if it was a part of WordPress core. But be that as it may, it's still pretty cool to have an API built right into the core CMS that you're using and to be able to leverage that. So for this category, I'll give the point to the REST API. So with all that, I would say, in my opinion, the best option for modern headless WordPress applications would be WP GraphQL. The REST API has a lot going for it, being included in core WordPress and being used as the primary API for Gutenberg, for being able to leverage the browser's built-in caching, like I mentioned, for client-side caching, and for being able to do file uploads more easily than WP GraphQL can. There's a lot going for the REST API, certainly. I think, though, that WP GraphQL has more things going for it. I think the single resource per endpoint model that REST APIs are built using doesn't quite work very well for modern applications, because it's very rare that you have a page on your site that needs just data about the author and nothing else. More often, we're building web applications where I need some data about the author and then that person's 3 most recent posts. And for each of those, I need the titles and the dates or something like that. You need some of these, you need to take advantage of GraphQL's ability to have nested, relationships and query for multiple resources all in one request. So to me, that's huge for building modern web applications. And as you saw, there are huge speed gains as well for GraphQL. You get exactly what you asked for back, no overfetching or underfetching, which is really great. We talked about how it has a strongly typed schema and introspection, which allows you to be sure about exactly what type of data you're getting back and what shape the data will be in. And because it has that, we also talked about how it has superior tooling as well. If I'm using a front-end tool like a GraphQL Playground or Graphical, which we saw, I'm able to compose my queries and mutations there, knowing exactly what data is going in and exactly what data is coming back because of those features of it. Let me know in the comments below if you disagree, if you think I missed any points here, if you think that the rest, there are other things that should be considered, or WP GraphQL, things I didn't mention should be considered there. Let me know, and happy coding. Thanks for watching, and I'll see you in the next one. Did you like that? Go ahead and push that like button. Subscribe.